Hey guys, so welcome back to your next class of Catalyst concepts. So in your previous class, you looked at what is the power of accommodation, right? It's the ability of the eye to change the focal length of its lens depending on what you're seeing, right? If you're looking at a far object, you'll have like a higher focal length, and a near object, you'll have a a lesser focal length, right? And we know that the limits for this are between 2.27 minimum focal length and 2.5, that is maximum focal length. So if anyone has anyone's eye lens is able to get to these two focal lengths, it means your vision is good. You can see anything at any distance. But sometimes some people are not going to be able to see beyond a certain point or up till a certain distance. Now, this can be due to a lot of issues. It can be, issue with the lens or the eyeball in particular. There's no set reason. But majorly, there are three types of issues, or what we call them as eye defects. Okay. We call them eye defects. So today we'll just cover a few of these eye defects. We'll start with the first eye defect, and that is called as myopia. Okay. Myopia is a defect wherein a person is able to see objects that are nearby, but not objects that are far. Okay. So until a certain distance, you'll be able to see, but beyond that, you will not be able to see. Basically, objects at infinity, you will not be able to see. Okay. We also call myopia as near sightedness, because obviously you can see only things that are nearby, right? So what is the issue exactly over here is, to see an object at infinity, you need your focal length to be the maximum. So f max should be 2.5 centimeters. If your lens is not able to reach this focal length, it means that you'll have myopia. Okay, you will not be able to see far off objects. Basically, your maximum focal length is less than 2.5. Okay. Now, so generally, what does it look like in a healthy human eye is this, right? You have a eyeball, you have light that comes parallel from infinity and then meets at the retina. This is healthy. But since our eye is not able to get a 2.5 centimeter focal length, right? The focal length is less. It means the light cannot meet at the back. It's going to stop somewhere ahead of it. Okay. This is less than 2.5, right? So it's going to stop somewhere in the middle of the eye. So that means the object is going to be looking very blurry. This is myopia. Okay. Now, for myopia, obviously there is a certain distance that you can see and a certain distance beyond which you cannot. We know that there is a least distance of distinct vision, right? What would that be? That is 25 centimeters. So say that you're able to see an object at 25 centimeters, and for that you'll have the least focal length 2.27, right? But beyond that, there will be a certain point until which you will be able to see. Okay, say in this myopic eye, say that this is the point at maximum distance at which you're able to see clearly. Okay, so So basically the light would come like this, and somehow it's able to meet exactly here. If the object goes any more behind from this, say over here, then your focal length is not going to be sufficient. It is going to give you myopia. It's going to give you this blurry image. So understood? So this, say, assume that this is some point until which a myopic eye can see. And this would be your least distance of distinct vision, maybe something like 25 centimeters. Okay. If any object is between these 2 points, you will be able to see clearly. Behind this, you will not be able to see. Okay. Since this is as far as you can see, we call this as far point. Okay. This will be your far point. Beyond that far point, you will not be able to see anything. Now, the big question is, how do we fix an issue like this? Okay, it's quite simple. We need to make sure that somehow the image should look as if it's between your far point and your least distance of distinct vision. Okay, say that this is your far point. Say that this is your, we'll just call it L. Okay. Okay. So normally any rays coming like this would not meet, like in this case. But if I have a lens in front of my eye, okay, I'm going to use a, if you remember the name of this, excellent, it's a biconcave lens. Okay. Say that there's light coming from infinity. Obviously, this eye will not be able to see because it cannot get the full length. But what this lens will do is it's going to deflect the light a little bit. I'm going to make this eye a little bigger. Okay. So this lens will deflect the light in such a way that it is going to go a bit away. Okay. Then once it meets the eye, it's going to come back and meet exactly at the retina. That is how some of the lenses work. Okay. Now, if I look at these deflected rays, if I trace back the path, okay, trace it backwards in this direction like this, Now, if you see, these deflected rays look as if the image was actually coming from here, which is between the far point and the least distance of distinct vision. So therefore, a biconcave lens, okay, a biconcave lens will help you fix myopia. Now, again, it depends on how bad your myopia is. Different biconcave lenses have different focal lengths. So you get your eye checkup, the doctor will know exactly what power lens to give you. Now, what this power is something that we are going to look at ahead. No need to jump to it right now. Okay, so this is our first defect, and that is myopia. Okay, so this is myopic eye with fixed, and this is a normal myopic eye. Main two diagrams that you need to know: the myopic eye and how do you fix myopia. There's no necessity to draw the F and L. You can simply draw the eye along with the lens and the parallel rays of light. Okay, that is generally sufficient to finish the diagram. Then it will meet. So healthy eye, myopic eye, and fixed myopia. With which lens? Concave lens. All right. So this is your first eye defect. Okay, so let's talk about the second type of defect, and that is called as hypermetropia. Okay, it's a lengthier name than myopia, but it's fine. So hypermyopia, metropia, also called as hyperopia at times, is also called as far sightedness. Okay, in all essence, it is the exact opposite of myopia. So everything will be contrasted. You try to see how it relates. Okay, in myopia we could not see because our lens cannot obtain the maximum focal length, right? In this, the case is opposite. Our lens cannot obtain the minimum focal length, which is 2.27 centimeters. So our minimum focal length is more than 2.27 centimeters. So as a result of this, what happens? You cannot see things that are close by. Okay, even at the 25 centimeter, the least distance of distinct vision, you'll not be able to see until a certain point. That is what hypermetropia does. Okay, so to give you an example, say a healthy human eye is here. Okay, say that this is some point over here at a distance. Okay, say this is the least distance of distinct vision. If a light ray comes through here, it meets the lens and then it deflects and it meets at the back of the eye, right? This is what a healthy eye will look like. But in hypermetropia, this focal length is not going to be less. Okay, it's not going to be anywhere close to 2.2, it'll be slightly more. So what happens over here is, in the same case, the eye at the same distance, since the focal length is not less, it's going to be higher. It means it is going to go farther than it's supposed to go. It will meet behind the eye. Okay, this is what hypermetropia looks like. Okay, when the rays are a bit delayed and they meet much after they are supposed to. So now, like I said, there will be a certain point until where you cannot see. Okay, so assume that this is the case and call this as L. Okay, this is some point in between, and there's going to be some point where you're going to be able to see. Okay, so ray of light coming like that. At exactly this point, your vision is fine. This is your minimum focal length, your own. And then you're going to be able to see. You'll also be able to see anything that is beyond this point. Okay. So this is basically the nearest you can see. So we will call this here near point. Okay. If I have to draw a diagram for anything that's beyond that, it would look something like, like that. So this is your L, so this is your near point. So say if there's something like here, it's still going to be able to come and deflect and meet in the right manner exactly at the back of your eye, but the others will not be. So basically this is your whole blind spot. Not blind spot, you'll not be able to see clearly in this range. So how do we fix this? We want to fix that with the exact opposite of the first method, and that is with the convex lens. Okay, so say that this is a hypermetropic eye. We use something called a convex lens. All right, say this is your near point, say this is the least distance of distinct vision, which is not really, yeah. Okay, now an object over here would come and meet, but it would look something like this, right? It would look like this. But if we use this lens, what's going to happen? The ray deflects over here a bit, okay? Because of this lens. Okay. Now, if I check the point of deflection and I try to trace it back, I'll see that it appears as if it is beyond your near point. Okay, your lens is going to be made according to that. It's going to appear as if your lens is, your object is beyond your actual vision. This is a convex lens. Sorry for the bad handwriting. Convex or biconvex lens. Okay, it totally depends on what is your how bad is your hypermetropia. The worse it is, the bigger the lens that you are going to get. Okay, so I'm going to stop here for today. Today we looked at two major eye defects: myopia, hypermetropia, nearsightedness, farsightedness. The issue being the focal length not being able to be the maximum or the minimum, and how to fix both of these defects with which types of lenses. 3 diagrams in each are compulsory: the healthy eye, the defected eye, and how do you fix that defect. All right, and again, like I said, the near point and this thing is not necessary. You can simply draw the diagram with the lens that shows that it is corrected like this. Okay, that it is deflected in the right manner. Although this diagram is good, even this diagram will do. Okay, so that's it for today. Tomorrow we'll look at the other defect that I spoke about, and we'll also look at some numericals. All right, if you have any questions, doubts, you can drop them in the comments below. And that's it for today. I'll see you in the next class. Thank you very much.